We live surrounded by invisible systems, power grids spanning continents, Wi-Fi signals bouncing through the air. The man who designed the architecture for this reality died in a New York hotel, effectively broke, spending his final days feeding pigeons. To understand how that happens, you have to rewind to 1884. New York City was gridlocked. Thomas Edison's direct current, or DC grid, was bleeding power. DC meant electricity flowed in one continuous line, but it lost pressure fast. Lighting a city required a noisy, coal-burning power plant almost every square mile, leading to skies choked with soot and streets tangled in heavy copper wire. Then, a 28-year-old immigrant from the Austrian Empire named Nikola Tesla stepped off a boat. He possessed an eidetic memory, the rare ability to visualize complete working machines in his head, and he held the mathematical solution to Edison's bottleneck, alternating current. Tesla carried the precise mental blueprints required to electrify the entire planet, but he arrived in America with exactly 4 cents in his pocket. He lacked the raw materials, the steel, and the labor to physically build his vision. Engineering brilliance requires a medium to take physical form. Without the financial backing of an aligned market, the greatest schematics ever conceived remain trapped inside the inventor's skull. Tesla actually went to work for Thomas Edison first. The relationship collapsed almost immediately. They clashed violently over the mechanics of the electrical grid, and Tesla walked out, citing promises of unpaid bonuses. Look at this animation detailing the physical mechanics of the two systems. Edison's DC power travels in a single, straight direction, friction eating away its strength over short distances. Tesla's AC power moves as a wave, constantly reversing direction, allowing it to interact with a crucial piece of hardware, the transformer. By passing through a step-up transformer, AC voltage can be multiplied enormously, allowing it to travel hundreds of miles over thin wires with almost zero energy loss. Once it reaches a destination, a step-down transformer reduces that massive pressure back to a safe level to power a household light bulb. The physics were flawless, but it took George Westinghouse, an industrialist who recognized the sheer scale of the AC polyphase system, to write the checks. He purchased Tesla's patents and absorbed the massive financial risk required to manufacture the physical turbines. That risk paid off at the 1893 Chicago World's Fair. Westinghouse and Tesla illuminated the massive exposition with alternating current, proving to a global audience that the AC grid could safely and reliably scale to power the industrialized world. A superior mathematical concept won the war, but it only became reality because a capitalist chose to underwrite the immense cost of its physical construction. With the wired electrical grid standardized, Tesla's mind immediately jumped to a much larger, abstract problem. He wanted to bypass wires entirely to transmit energy and information through high frequencies. He began experimenting with massive high-voltage transformers, devices we now call Tesla coils. He pushed millions of volts through them, generating violent electrical discharges to physically prove that wireless transmission of power was an observable fact. This led to his most aggressive proposal, Wardenclyffe Tower. The plan was to build a global network of huge lattice structures that would pull energy from the Earth and broadcast it through the atmosphere, providing free wireless power to anyone, anywhere. To build it, he secured funding from the incredibly wealthy J.P. Morgan. But Morgan eventually recognized a fatal economic flaw in the architecture. If you broadcast invisible power through the open air to everyone, you cannot attach a billing meter to it. Morgan halted the cash flow. Without the money to purchase steel, copper, and labor, construction on Wardenclyffe stopped entirely. The tower was eventually scrapped to pay off Tesla's mounting debts. Innovation operates at the mercy of the ledger. A market mechanism will inevitably choke off the capital to any technological leap that destroys its ability to measure and sell a product. Following the collapse of Wardenclyffe, Tesla retreated. He spent his final decades moving between New York hotels, paralyzed by financial ruin and deepening obsessive-compulsive routines, developing a profound fixation on the numbers 3, 6, and 9. While he sat in isolation, other inventors leveraged the market. Guglielmo Marconi utilized Tesla's foundational wireless patents to build the first commercially successful radio, capturing the Nobel Prize and immense personal wealth in the process. It took until 1943, shortly after Tesla died completely broke, for the U.S. Supreme Court to officially invalidate Marconi's claims and legally recognize that Tesla had invented the radio first. He lost the financial battles of the 19th and 20th centuries, but step inside any factory, power plant, or electric vehicle today, and you are looking at his direct physical legacy. In the International System of Units, the standard measurement of magnetic flux density is literally called the Tesla. Tesla understood this trade-off long before he died. Reflecting on the men who commercialized his patents, he stated, "The present is theirs. The future, for which I really worked, is mine." He gave up his own immediate wealth and stability to map the physical mechanics of the century to come. The market ultimately dictates who gets paid today, but the visionary writes the operating system for tomorrow.